Don't know much about algebra. Don't know what a sliding rule is for. But I do know one and one is two. This one could be the you. What a wonderful world this would be.
Good afternoon, everybody, and welcome to Mr. K's 30 Minutes of Math. I hope you all had a great weekend. The weather was beautiful, and I hope you had a little bit of a chance to enjoy it despite all the current circumstances. So let us dive right in. I'm going to start off with our math riddle from last Friday. I'm going to turn off the video so I can focus on our riddle. 1 second here. All right. So let us see what our riddle was. We had another tangram riddle. This time we had 7 shapes, same 7 shapes, and the goal was to make one perfect triangle. And as a reminder, we have 2 large triangles. I'll call that LT1 and LT2, large triangle 1 and large triangle 2. We had 1 medium triangle. We had 1 square, 1 parallelogram, and 2 small triangles. Small triangle 1, small triangle 2. So that is your standard set of parallelograms. And unfortunately, I don't have my sound machine today, so I'm going to do a homemade drum roll. Here it is. The answer for Friday's math riddle, there it is, ladies and gentlemen. So as a reminder, here's large triangle 1, large triangle 2. Here's our medium triangle. Here's small triangle 1 and small triangle 2. Here's our parallelogram, and here is our square. There are hundreds of different designs you can do with parallelograms. So if you haven't had a chance to print these out and cut them out and use them, I would encourage you to do so. You can look up all kinds of different puzzles online. All right, let's move on to our math for the day. Here is the homework that we had, and what we were doing, let's highlight this, estimate the answers by rounding to the nearest whole number, then calculate the exact answer and show it as a mixed number. So this is putting all of our work together. So 101 1/100ths, well, that's really close to plain old 1. Because we know 100 hundredths would just be 1. Then we have minus 1/50th. 1/50th. Ooh, that's really close to 0. Then 22 25ths. That's pretty close to 25 25ths, which would be 1. And then finally, we have a quarter. Is a quarter closer to 0 or 1? It is closer to 0. So if we estimated, we'd have 1 minus 0, which is 1, plus 1, which is 2. Now, if we were going to calculate this exactly, let's do some decomposition. Remember, our estimate was 2, so I'm going to write that up here. Estimate was 2. All right, let's see how close we get when we do it all with all the details. Okay, so let's look at what fractional amounts we have. We have hundredths, 50ths, 25ths, and fourths. Okay, so I am going to decompose our 50ths, 25ths, and fourths into hundredths. So let's see, 1/50th gives us how many hundredths? Well, I can decompose it into 2 hundredths. All right, so that's this guy. Then 22 25ths, Let's decompose those 25ths into hundredths. And to do that, we have to multiply the numerator and denominator by 4 because 25 times 4 is 100. 22 times 4 is 88 hundredths. So that's this guy. Then 1/4, if we decompose that into hundredths, well, 4 quarters is $1. 4 times 25 equals 100. So 25 hundredths is that guy. Okay, so I'm going to rewrite this. 101 100ths minus 250, excuse me, 2 100ths plus 88 100ths plus 25th 100ths, 25 100ths, okay. Well, we have 101 minus 2, that would give us 99, plus 88 plus 25. Let's do that up here. 9 plus 8 is 17, plus 5 more gives us 22. I have 2 10s to carry over. 2 10s and 9 10s is 11 10s, plus 8 more is 19 10s, plus 2 more is 20 10s, also known as 200. Okay, so that means we have 202 100ths. We do our number bonds. 100 100ths is 1 whole. Another 100 100ths is another whole. That's 2. And then we have, I'm running out of room, 2 100ths left. So our answer would be 2 and 2 100ths, which is very close to our estimate of 2. All right, well done, everybody, well done. Let us see. I see we have some folks writing in. Yep, no problem if we made a tiny error. That is no problem at all. All right, let us move on to a few more problems just like this. This time, though, one little difference. I want you to round to the nearest half or whole. Half or whole. Okay, so if we can get close to the half, let's do that. Go ahead, take a couple minutes to work on this one. I'll give you a little bit of music. Okay, welcome back, welcome back. I'm curious if anybody has an estimate for us to consider. 1/9 plus 9/18 minus 3/6 plus 8/9. We have Ezra writing in with an estimate of 1. Anybody else have any estimates they'd like to share? We have an estimate of 1. Anybody else? All right, let's give it a try. 1/9. Is that closer to 0, a half, or 1? 0, a half, or 1? Well, 1/9 is almost 0/9, so let's call that 0. 9/18. 9/18. Well, I hope everybody realizes 9/18 is halfway between 0 and 1. So that would be a half. 3/6. Again, halfway between 0/6 and 6/6. So that's a half. And 8/9 is almost 9/9. So let's round it to 1. So we have a half. 0 plus a half is a half. Minus a half, well, that's 0. Plus 1 equals 1. Well done. And I see a number of folks wrote in. Fantastic. We also have some folks who wrote in that the exact answer is 1. Well, let's check it out. All right, let's check it out. Sometimes your estimate and your exact answer are exactly the same thing. Well, we can do this in a couple of different ways. I hope you saw that we have 1/9 and 8/9. If we add 1/9 and 8/9, we're going to get 9/9, which equals 1. All right, so that takes care of those. Let's cross those out. And then we have 9/18 minus 3/6. Well, I hope we saw that 9/18, as we just talked about, is a half. And 3/6, we just talked about, is a half. So 1/2 minus 1/2 is 0. We can cross those off. So we're left with just 1. Well done, everybody. Well done. Very, very impressive. I am so happy to see how you guys are doing. You're making me very, very proud. All right, let's do another one. Go ahead, give this one a try. Okay, welcome back. Oh, that music is so much fun. It's hard to press stop on it. We have a few folks writing in. Delilah with the exact answer of 19/20. Ezra with an estimate of 1.5. A couple others that I'm seeing as well. Well, let me walk through this one with you guys. 4/5. Is it closer to 0 or to 1? 4/5. We're just 1/5 away from 1, so that rounded is 1. 1/10. Well, that's just 1/10 away from 0/10. So let's go with 0. 9/20. Well, that's 1/20 away from 10/20, and 10/20 would be exactly half. So let's go with that. And then 1/5 is just 1/5 away from 0. So let's go with 0 there. 1 plus 0 is 1. Plus a half is 1.5. 1.5 minus 0 is 1.5. So yes, our estimate is exactly 1.5. Well done, well done. Let's do our exact calculation now. Okay, here we go. Again, there's lots of different ways to do this, but let's try it by looking at our fractional units. And you'll see that we can decompose all of these into 20ths. So I'm going to start with my 4/5. I'm going to decompose fifths into 20ths by multiplying our numerator and denominator by 4. So 16/20 right there. Now I'm going to decompose my tenths into 20ths. Multiply the numerator and denominator by 2. So 2 20ths goes right there. Then we have 9 20ths. We don't have to do anything on that one. And then 1/5. Let's decompose our fifth into 20ths. We can do that by multiplying our numerator and denominator by 4. And that gives us 4 20ths. So let's rewrite this. We'd have 16 20ths plus 2 20ths plus 9 20ths minus 4 20ths. All right, 16 plus 2 gives us 18 20ths, plus 9 more gives us 27 20ths, minus 4 gives us 23 20ths. Let's do our number bonds. 20 20ths, that's one whole, and then we have 3 20ths left. So your answer is 1 3 20ths. So this time, our estimate wasn't quite as close, but we were in the ballpark nonetheless. All right, let's get to, I'm going to skip this one and go straight to our joke for the day. Here it is. What did the tiny seed say when he grew up? And I will give everyone a little bit of Jeopardy music for this one. All right, we have a few folks writing in. Ezra G, I'm a tree, and Delilah, I'm a big boy now. Well, that's pretty good, pretty good. Yes, the answer is G, I'm a tree, which sounds a little bit like geometry. If I had my groaner sound, I would do it today. I'm sorry, I don't have it. So I thought we'd use this as an opportunity to do a little bit more geometry. We started looking at our coordinate plane. That's what this thing is called, a coordinate plane. Coordinates are the dots that we can name with the numbers, and a plane is a flat surface. So let's go ahead and remember a few things. Does anybody remember what you call this line or this line? It's a word that starts with an A. Remember, it's 4 letters. This one's I. Anyone else remember? What do we call those lines? An axis. Well done, Delilah, an axis. And the horizontal one, whoops, I'm going to take that off. The horizontal one in blue is the x-axis, and the vertical one, and I'll do that in red, is the y-axis. And then remember, as we go up on the y-axis, we count up 1, 2, 3, 4, and so on. As we go down, we count negative, -1, -2, and so on. For the x-axis, same thing. When you go to the right, you count up 1, 2, 3, 4, 5. And when you go to the left, you count down -1, -2, -3, and so on. And right in the middle, where they cross, anybody remember what that is called? Right in the middle, O. Anyone remember what that is called? Let's see, I'll give you 2 letters, O-R. Anybody remember? Fantastic, origin, that's right. That is the point where the 2 axes cross. By the way, the plural of axis is axes. That's kind of funny. It looks like axes, but it's pronounced axes. Okay, enough English lesson for today. Let's get rid of all of this. Now, as you might recall, we can give a number pair to each dot on our coordinate plane. So right here, I'm going to do this in green. Whoops, let me get that going. That green dot we know is 1, 2 spaces to the right on the x-axis. So we put the x-axis number first, then a comma, and then it's 1, 2, 3, 4 spaces up on the y-axis. So we would call that point 2, 4. All right, let me show you one more. I'll do this one. And actually, let me do that in a different color so it's easier to see. How about, let's do that one in orange. All right, that one is 1, 2, 3, 4, 5, 6 spaces to the right on the x-axis, and then 1, 2 up on the y-axis, so we call that 6, 2. All right, I would like everybody to go ahead for a second and tell me what would, whoops, my apologies. What would this one be, the blue one? Go ahead and take a second to determine what would the blue point be? What would its coordinate pair, that's what we call them, coordinate pair. So we have a few people beginning to write in. To make this easier, I'm going to clear this off so you can see things better. Folks are writing in 4, 3. Let's check how many on the x-axis. 1, 2, 3, 4 across to the right, and 1, 2, 3 up on the y-axis. Very good, 4, 3. And let's do another one. How about, ooh, let's see if you're paying attention. This green one, what would that be? Take a second and try that one out. This green one all the way up here at the top. All right, I see some folks writing in. 1 across. And how many? 1, 2, 3, 4, 5, 6, 7. Very good. Excellent. Well done, everybody. All right, now, I do want you to see they don't all have to be over here. They can be anywhere. So, for example, look at this red one. Let's do this. Whoops, sorry about that. And sorry about that. Let's do this red one right here. What do you guys think that one would be? That red one. All the way over. So remember, we're going to do our x-axis first. This time we're going left. 1, 2, 3, 4, 5. It's not 5, it's -5. Well done, Delilah. And then we're going up. 1, 2. And remember, up on the y-axis is positive, so -5, 2. Well done, well done. All right, let me give you one more to try. Let's do this green one. How about this one right here? What would that one, the green one, be? Take a second and try that one out. Remember, we do our x-axis first. We go across first, either right or left, and then we do our y-axis. We do x and then y. So go ahead and take a second. We have folks writing in 5, -5. Let's see. 1, 2, 3, 4, 5. Very good. And then -5. 1, 2, 3, 4, 5. Excellent job. Well done. If I had my applause, I would do my applause. All right, here's what I'd like to try now. Let's erase all of, oh, I'll put my origin back in. We need to have our origin. Okay, here is my little brain teaser for you on this. Let's say we had a square whose corners were at 3, 2, and 3, -2, and once, I'm making sure I'm doing this right, -1, 2, The question is, what is the last corner going to be at? So your corners are at 3, 2, 3, -2, -1, 2, and then what would your last corner be at to make a square? Go ahead and take a minute to figure that one out. There's some music. Okay, welcome back everybody. Let's take a look at this one. We're creating a square and have to find the missing corner of our square. We're gonna start with 3, 2. So we start with the x-axis, 1, 2, 3 to the right, and then 1, 2 up on our x-axis. All right, there's our first point. Let me erase this so we can see it. Then the next one is 3, -2. All right, again, first the x-axis, 1, 2, 3, and now -2. So we're going down on the y-axis, 1, 2. So our next point is right there. Let me clear that off. All right, next is -1, 2, -1. Starting with our x-axis, we're going to go to the left, -1, and then 2. We're going up 2, 1, 2. So right there. Whoops, I erased our point. Okay, so our square goes like this, goes like this. The question is, where does it finish? Well, it looks like it's 4 tall and 4 wide. So our final point would be right there to make our square. And what is that one? Well, it is 1 to the left. We know that's -1. And then it's 1, 2 down, and we know that's -2. So -1, -2. Well done, well done. Very impressed with everybody's work. All right, let's get back to fractions. Let's just do a couple more. Go ahead and try this one. I know it looks crazy, but if you just think for a second, it goes really fast. Go ahead. Okay, welcome back everybody. I know this one looks a little bit crazy with all those really big numbers, but I know you are all well prepared to handle these because you understand the fractions. So that's what's cool about this. 999 1,000ths is almost 1,000 1,000ths, and we know 1,000 1,000ths would be plain old 1. Then we have 1,001 1,000ths, which is just 1 1,000th more than 1,000 thousandths, which also is really close to 1. And then we have 500 thousandths. Well, 500 thousandths is right in the middle between 0 thousandths and 1,000 thousandths, so we know that's half. So there you have it, 1 plus 1 plus a half equals 2 1/2. And you know what? If we did this exactly, we are going to find the same thing, because 999 thousandths plus 1,001 thousandths is actually just 2,000 thousandths. And we can do our number bond, 1,000 thousandths and another 1,000 thousandths. That's 1 and that's another 1, so that's 2. We already know 500 1,000ths is a half, so the estimate and the actual answer are 2 1/2. Well done, everybody, well done. All right, let me just give you one for homework. I want you to write this one down and then we'll do our riddle. Here's our homework. 1,000,001 1/millionths minus 1/1,000,000th. I know there's a lot of zeros there, but just think about it and you will be fine. Write it down, take a picture, do a screenshot so you can work on that one. All right, finally, this is the math riddle of the day. I'll bring back the video just to say hello before we go. Obviously, 12 by 12 isn't 9, and 23 times 23 isn't 16. There's a pattern going on here, so the goal is to figure out what it is and then figure out what goes in the question mark. All right, everybody, thank you so much for joining us today. I'll see you back tomorrow. Have a great afternoon. Bye.